Okay, this is lesson number 7, and as you can see, represented more sequences using recursive or and term or and formula. Let me go straight away to the practice problem. This is lesson 7, and go to practice problem. Here it is. The first problem is here is a recursive definition. So let me. So if you see here is a recursive definition. The first part is given f of 1 is 0, so we can make a table. As I always like to see the visuals and the when this is 1, that means the very first term is 10, and this is n, and this is f of n. And then 2 and 3. So what it says is this recursive definition clearly says, so this means any term is always the one before the one before. So that's n minus 1. And then you take away 1.5. It means from here, if I want to figure out this is f of 1, so this is f of 2. So f of 2 is the previous one, that is f of 1 minus 1.5, which is 10 minus 1.5, and which will be 8.5. Then if I want to figure, so this is 8.5. If I want to figure out how much, what is this one? So that means this is f of 3. So because of the recursive definition, we can write this as f of 2, the one before, and then minus 1.5. The one before is 8.5, and then minus 1.5 will give you 7. So this is how you're supposed to do, and this is recursive. The question is this arithmetic? Yes, because you're taking away 7, both 1.5 each time, so you minus 1.5. So this minus 1.5 is the common difference, or it's also rate of change, so D, because the recursive formula is always f of n, maybe, and f of n minus 1 before, and then plus D, and this is n greater than equal to 2, because you already know the first one, that is f of 1, which is the very first term. Sometimes the first term is written as single letters lowercase a, and in this case it is this one 10, and you're done. So we also listed the first 5 terms. That means if I want to write next, then this again you go down. That is minus 1.5. That will be 5.5, and again go down. 1.5 will be 4, and that's how it will. Then you can also graph this. What that means is you can easily start with, because it starts with 10. So if I start this with 10, and then 1, 2, 3, 4, 5, and then you have 1, 2, 3, 4, 6, 7, 8, 9, and then we can graph this. It starts with, not here, sorry. It starts here, 10, and then it will be going down. So this will be 4, something like this. So you can check that, okay? So this is how you're supposed to graph. Let's move to the next question. This question, the arithmetic sequence. So this is already arithmetic sequence, which starts with 12 and then 6. And that means because it is k, so I can say 1, 2, 3, 4, 5, and 6. And this is k. And the first one is given to you, this is 12. And the second one is 6. And because it is arithmetic sequence, you only have to see how much goes down. And you can see it is minus 6. That's the rate of change which is also called common difference. So that means how do we write a recursive? This is the most important. How do we figure out the recursive? And not only that, I'll add one more question, write also the n term, because the lessons later class we have all this. The first thing is to write the recursive. So the formula says the very first term, the number in the first position is 12, and after that any number in any position, that means n could be any position, that is always the one before n minus 1, and then you're taking away this d, so this is minus 6, and this is n not just 2, not just 3. It's anything greater than equal to 2, which could be written as inequality sign 2, and this complete. This is called recursive. This is called recursive definition. But the same question was asked also, what is the nth term? Now, what is the nth term also means explicit formula. So how do we write explicit formula? You kind of create an equation. So you write Kn. So start with the first one, and the first one is 12. And then every time, so let me write here, every time it is right. So if you get confused, still I would like to explain that. That means you're good. If I want to find out this K2, or this is K2, so K2, it is 12, and you're taking off minus 6 here, see? So it is like 6. So you're taking off 6 one time. So that's what that means, right? And then suppose I want to find what is this one is K of 3. So that means you have to do one more, take away another 6. That means if it is K3, the beginning is 12, and you're taking off 2 of them. So that means this will be 0. Now again you take off minus 6, you get minus 6. That means if you, what's the relation from 12? So this is the one which is a beginning, and then all the way here, or until here, if I want to find K of 4, it means you can see this is 4 and the answer is negative. So you are going down minus 6 and another minus, so 3 of them. So we'll write this equals the 12 is what was before, and then times 3, and clearly see the relation. This is K4. So this K4 is the one that is in the beginning minus 6 times. I can write this 3. This 3 can be written as 4 minus 1. See? So therefore, your final answer we can write is, and in Kn, so here it is, Kn is minus 6, and then you write parenthesis and say 1 less. And this is n greater than equal to 1, not 2, but it is 1, because it starts with 1 here, then 2, and then 3. So n is 1, 2, 3, 4. Now this is a good practice how to write this nth term or explicit formula instead of this is recursive, this is explicit, where very similar to the one that you did in the algebra one, which is y equals mx plus b, where in this example the b, that is this b, is like a y-intercept. So that's where the start. This is that b, and the m that you see here is the slope. That means you're going down by 6, and this is this is n minus 1, which is x. This is the x here. So only thing that you have to take is here. This starts with x could be anything. If I put 0, it means I'm making this n minus 1 equals 0. It means you add plus 1 both sides, and you get n equals 1. So that's why it is not just 1, but also greater than 1. I hope this helps. And you're done. And it says also you have to graph this. So if I want to graph this again, do the same thing. Start with 12, and 1 is 12. So 1, 2, 3, 4, 5. So that's where it starts. Then 1, then 2 is 6. So 2 becomes halfway down like that. Then 3 is 0. So this is 0. And then it is going to be minus 6 next one. So this is 3, then 4, and that's how you do. So those are the point, maybe here, sorry. So that's 4 is minus, so this is 3 is 0. This is 2 is 6, and I made a mistake here. This 12, so 1 is 12, so that's where it starts. So hope that helps. Let's move to the next. So this is an arithmetic sequence. So 11, 7, again, yes, sir? Hmm. Make a table, and now the sequence name is A, so I write A N And 1, 2, 3, and 4. And this is n. So it starts with 11. So I'll write 11, then 7. It goes by 4, right? So it's arithmetic sequence. So this is that D, and again goes down. So this will be 3, goes down. So each time you take away 4 and you get this. So the question is, so we know the answer, the first five term, but can we write the recursive? So how do we write the recursive is the very first one, A1. So always remember, first one is 11, and then so this is A1, okay, and that is A2. This is A3. So any one, we write A of n. Any the number in any position is always. So let's say, let's imagine you want to know what is this A4, right? How did we get this A1? It is because you are using this A of 3, because A of 3 is 3, right? So it's the one before 3 which is there. So we say, okay, A of 1 before. So if this is n, we get this is n, this will be n minus 1. And your plus, the formula says plus d. This is actually the formula, but we write it as an is an minus 1, but d is here, d is minus 4, so that's my negative 4. And this is good for 2, 3, 4, and greater than or equal to 2. How to use recursive definition to find? Now, recursive definition also without determining the value. So there's another question they're asking, explain how to use the recursive definition to find A of 100. So that means you start with 11 and then you go on working on 7 and go on working on this until you get A of 100, and then you can get the answer. But there is another question is, how do you write the explicit formula? So again, I want to show what the explicit formula is. An is the very first one. So I put A of 1, the first one, plus, and then you do n, the d, that means how many times you multiply this d in n minus 1. So this means the first term, and this part basically means d is multiplied to n minus 1. So if I want to apply this here, from here, right? So the answer is an is, the first one is 11, and d is minus 4, and then you put n minus 1, and this is true for n greater than or equal to 1. So this is how you get the answer. This could be also another way to write is, you could write an equals 11 minus 4n also. But if you write that, then you have to write n greater than or equal to 0. Still, this also is valid, because if I put here n equals 0, so it's like the number in the beginning, it will be 11 minus 4 times 0, you get 11, see? So still you get the same sequence. Let's move to the next. Now for this question number 4, it's better to pause the video and see if you can do it by yourself, and then you can check the solution that I'm showing. So you have the first number 80, and the moment you see this 80 and then 40, you already know what's going on. So 80 to 40 is half, and it is a geometric sequence. So it becomes half of that. And the name is G, so I'll put a GN. So two things you're supposed to write is what is recursive definition. So you multiply one more half, you get 20, and one more half. So every time you multiply half, and that's the common ratio or growth factor. But then what is the recursive formula? The recursive formula is always Gn, any term, is G of the previous one, that is 80 maybe, and then you multiply. The formula is R for n greater than 2. So, but then we write G of n is G of n minus 1, but the ratio here is half. and this is n greater than 2. But what about n equals 1? But so you have to mention that the first one is 80. So this is the right way to write the recursive. But if you want to write the explicit formula, so the explicit formula is g of n is, so the first it starts with 80, and then time. And you see the good thing is, so if I want to find 2, that means if I want to find g of 2, you are multiplying half once. So just multiplying, but so 80, the half is multiply once. If I want to, so this is 80 times 1 half, right? So if I want to know how did you get this 20 from, that's because g of 3, so you start with 80 and then you multiply another half. So there are two halves multiplied. So it is like half square. See? So watch this trend there. And if this is 3, this is 3 minus 1. So like that, you can write down directly that half raised to, if this is n, so this is n, this becomes n minus 1. And all this is starts with 1, there is 1 greater than 2. So there is a difference between here starting 2 here and then here starting is 1 here. Sorry, I made a mistake. This starts with 2. So this starts with 2. This starts with 1. That's because this g of 1 is taken care of. So you already know what is g of 1 is 80 here. In this case, we straight away we plug in, suppose you plug in 1 here, so g of 1 is 80 times half raised to 1 minus 1, but 1 minus 1 is 0, and you can clearly see uh, it is going to be 80 because half raised to 0 is 1, which is 80, and that's how you can write explicit formula, or also now I'll explain how to use recursive. This means if I want to find g of 100 using the recursive definition, you start with 80 and you go on doing until you get 40, then 10, then next one 5, then 6 2 point, and you go on doing, and you get something like 0.000 and something like that. Okay, let's start with this. Question number 5 says the very first one is 1, right? So in all this problem, you look up whether it is this, then you can see in this cases you have, there is a 1 here. Clearly see, there is 1 in both cases. But then what does this recursive definition says is, you have that 1, but then in this, the next one, so this it means you double, this means you double the previous and then add 1. So you look up which among these two you double and add 1, and you can see this part, which is here 1 3 7 15, and you can see how you double this. It means you 2 times 1 and add 1, which is 3. This means what? You 2 times the 3 which is here and you add 1. So naturally this is how you have to explain. What does this mean? The very first one is 1 and then this one is just double. See this? That means clearly this is doubling. See? So you get 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and then so on. And what does this mean? It starts with 80. You already know the answer is 80, but why? What does this mean is, in any number in any position is always half of the one before, and that's what we have already done. And you can see how this is what we have already done. Question number 6. Look at it. Decide whether it could be arithmetic. And by the look at it, just you can see here the number becomes 1/5. So start with 25, then become 5, then becomes 1. It means you are multiplying by 1/5. So that itself is the ratio. See, again you are multiplying by r, which is 1/5. So you have, if you want to write recursive definition, so we can also write and call this as a, right? This is one, this is n and a, and then you can say, okay, a n is uh, the start. So the previous one, that is an minus 1, and you multiply the 1/5. And this is good for n greater than 2. But what about the first one? A1 is 24. This is how you write the recursive definition. But if you want to write the nth formula, you have to write an equals the beginning is 25. We write 25, the first one. So always start this. So if it is the explicit formula, you have to write 25, and then this ratio, which is 1/5. How many times do you multiply 1/5? It will always one less, and this is n greater than equal to. So the goal of this showing these examples is to get more practice in understanding, not just knowing arithmetic and geometry, but also write explicit formula and recursive definition. If you watch the second one, you can see 25, it goes down by 6. So if I write this, the B, N and Bn, this is 1, 2, and 3, and 4, and 5 like that. So 25, 19, and 13, clearly watch this. So it goes down by 6. So that's the D. So it goes down by 6. So each time it decreases by 6, and you get 7 here. So what I'm trying to say, if I want to write recursive, then you have to write, okay, the first number is 25, so B1, and any position the number is always the one before n minus 1, and you subtract 6, and this is n greater than 2. At the same time, yeah, that's it. This is recursive, but if I want to write the explicit formula, then it is Bn is in the beginning you have 25, and then you're going on decreasing 6. How many times? N minus 1, and here you write n greater than 1. This is explicit formula. So on the chart I have already the formulas, you just have to use them. This is explicit formula for arithmetic sequence, and hope this helps. Thank you.